Alright, Chapter 8, Ballast. Layer with a broken stone, gravel, the mortar, and any other granular material placed packed below with it around the sleep of the distribution load from the sleep of the formation to provide the drainage, well, the longitudinal lateral stability of the track, different type of the ballast materials. The specification discussed in this chapter. 8.1. Function of the ballast. Ballast serves the following function of the railway track. Provide the level and the hard bed of the sleeper to rest on, hold the sleeper's position during the passage of the train, transfer the distribute the load with the sleeper with the large area with the formation, provides elastical resilience to the track, proper riding comfort, provides the necessary resistance for the traction, longitudinal lateral stability, provides effective drainage to the track, provides an effective means of maintaining level alignment of the track. 2.8.2. Type of the ballast. The different type of the ballast for the use of the Indian railways are described as the following. Sandblast is used with the prime limiter cast iron pods that is used with wooden steel to deal with trough sleepers. Any other with the traffic that tends to very low coarse sand is preferred to the corresponding of the fine sand with the coated drainage property, but has drawbacks of blowing off because of the being light, and it also causes excessive wear of the rail top of the moving parts of the rail rolling stock. Mormon ballast. The decomposition of laterite result with the formation Mormon, the red with sometimes yellow is called the Mormon ballast. Mormon ballast is normally used within the initial ballast. The new construction and also with the sub ballast also prevents the water from the percolating in the formation. It's also used for the blanketing material from the back hull and cotton soles. Soil. Coal ash cylinder. The type of the ballast is normally used for the yards and siding of the initial ballast. In the new construction, the very cheap, the easily is available. The harmful for the and it's harmful for steel. Super fitting with the becomes and fittings becomes the corrosive action. Broken stone ballast. The type of the ballast is used for the most Indian railways. The good stone ballast is generally procured with the hard stones such as the granite, quartzite, and the hard trap. The quality of the stone should be seen such that neither of the porous nor does it affect the flake due to the vagaries of the weather. Good quality of the hard stone is normally used for the high-speed tracks. The type of the ballast work without to be economical in the long run. Other types of ballast. There are other types of ballast, but also for the brick ballast, the gravel ballast, canker, stone ballast, and even earth ballast. The type of the ballast are used only with the special circumstance, comparative advantage, disadvantage, suitability of the different type of the ballast are given in Table 8.1. Alright, sand ballast advantage is good drainage, properly cheap, no noise produced on the track, good bracking of the material of the CI sleepers. Cast iron sleepers with disadvantage cause excessive wear blows off easily. Power potentially packing stragging cannot be maintained to the high standards. Suitability suit for the cast iron pot sleeper tracks no suitable for the high speed, not suitable for a high speed track. More ballast, cheap if locally available, prevents water for the percolation, provides a good aesthetics for disadvantage versus soft turns into dust maintenance for the traffic difficulty quality of the track. Suitability, move the sub-ballast, initial ballast for the new construction, continued coal and ash cylinder, easily available to railways, very cheap, the good drainage, the disadvantage harmful for the steel sleepers, the corrode of the rail bottom, the steel sleepers is often evenly polarized, maintenance and difficulty. Maintenance is difficult, normally used in the yard siding, suitable for the repairs and formations during floods and emergencies, new fit with high-speed tracks, not fit for high-speed tracks, broken stone ballast. Hard durable wear procured with the hard rocks, good drainless property for the suitable to resilient to the track, economically long runs. Disadvantage initial cost is high, difficulties of procurement, angular shape that may be injure the wooden sleepers, suitable for the packing of the wooded track machine, suitable for the high speed tracks. 8.3. Size of the ballast. Previously, 50 millimeters or 2-inch ballast was specified with the flat bottom sleepers, such as the concrete wooden sleeper. The 4 millimeters, 1.5-inch ballast was specified for the metal sleeper, such as the cast CSC and trough sleeper. The new, not to ensure the uniformity of 50 millimeter ballasts have been adopted universally. All the type of sleepers. As for points crease, was concerned, these all subject to heavy blows, moving the load, and maintained with a higher degree of the precision of small size 1-inch ballast is therefore preferably cover the finance with a slight adjustment before compaction and frictional air of the ballast. 8.4. The requirements of the good ballast. Ballast material should possess the following materials. It should be tough enough to wear. Resistant should be hard so that it does not get crushed under the moving loads. Should be generally cubical and sharp edges to be non-pure. If the should not be absorbed with water. Should be the resist both attrition and abrasion. Should be durable. Should not be pulverized, disintegrated in inverse weather conditions. Should always be in good drainage of the water and should be cheap and economical. 8.5. Design of the ballast section. The design of the ballast section includes the determination of the depth of the ballast cushion below the sleeper and its profile, the aspect that discussed below. The 8.5. Minimum depth of the ballast cushion. Load sleeper to transfer through the minimum of the blast to the formation. The pressure distribution of the ballast section depends upon the size, the shape of the ballast, the degree of the consolidation of the lines of the equal pressure, the shape of the bulb. Yet the simplicity of the dispersion of the load can be assumed with roughly the 45 degree of the vertical in order to observe the load is transferred and evenly on the formation. Depth of the ballast should be such that dispersion decimal lines do not overlap each other. For the even the distribution load of the formation depth of the ballast is determined the following formula figure 8.1. 8.1 shows the minimum depth of the ballast cushion dimension in millimeters, spacing of 635 millimeters, 254 ties, 45-degree angle, 1095. Sleeper spacing width of the sleeper is +2 with the steep depth of the ballast. The big broad gauge to the lake with the wooden sleeper density at the end +6. Sleeper spacing of 68.4 centimeters. The speed of the sleeper is 25 centimeters. The depth of the ballast cushion would be depth equals 68.4 minus 25.4 divided by 2 equals 21.5 centimeters. Minimum cushion with a 15 cubic, 15 to 20 centimeters ballast below sleeper bed is normally prescribed in Indian railways. This is different because I've actually done the Ace Course correspondence, Army Corps of Engineering and Rehabilitation and Design. So go get your measurements from there for the U.S. track. Ballast profile and fish-plated track. The profile of the fish-plated track is shown in Figure 8.2. The requirements of the ballast, a different group of the rail lines adopted by the Indian Railways are given in Table 2. Standard ballast 1 and 1, 140 and 1617. This is in millimeters. Also, it differs from standard railway in America. 8.5 ballast profile along welded railway track. The ballast profile with a long welded rail track is shown in Figure 8.3 with the requirements of ballast for the type of the different sleep of the big broad gauge railway line are given in Table 8.3. The minimum clean stone ballast shown below the bottom of the sleeper A is in 250 millimeters for the route with the speed, but is also to be more than 130 kilometers an hour. A 300 millimeter, 200 millimeter along with a 150 millimeter sub ballast. Suitable dwarf walls should be provided with in case of the cuttings necessary for the retaining of the ballast. Necessary suitable dwarf coating is provided with the cutting of the retaining the ballast. The H sheet and the height suitable slope 100 millimeters. F1 cutting, F4 embarkment ballast level. 8.6 specification of track ballast. The following specification of the ballast, which recently have been revised June 2004, filed with the Indian Railway. The specifications are applicable to stone ballast to be used with all types of sleepers on normal tracks, turnouts, tunnels, and deck slabs on all routes. 861 general qualities. The ballast material should be possessed with the general qualities described below. Basic qualities should be hard, durable, as far as possible angular, large, along the edge of the corner, free of the weathered portion of the parent rock. Organic impurity of the inorganic residue. Ballast particular shape. Ballast should be cubical in shape as far as possible. Individual pieces should not be flaky. Should have flat faces, generally with not more than 2 of them round or sub-round faces. The mode of manufacture ballast of all the broad gauge main lines, running lines, except for the E routes, must include the E special routes should be machined and crushed for the broad gauge line with the major meter gauge, non-gauge, narrow gauge routes for playing with the stage sanction. Reversion of the ballast should be preferably machine crushed. Hard broken ballast can be used with exceptional case for the prior approval of the chief track engineer or the chief of the administrative officer. Such approval should be obtained prior to the invitation of the tender's high and broken ballast can be used without any formal approval of the meter gauge or narrow gauge route not planned and sanctioned for the version. 8.2's physical properties. All ballasts should possess the physical properties given in 8.4 when the test is in accordance with the IS 2386I4 1963. Characteristics: aggregate abrasion 30% maximum minimum planned sanction and conversion. Narrow gauges 35% maximum planned and conversion. Aggregated impact 20% maximum planned sanction and conversion. Narrow gauge minimum maximum gauge meter gauge 30 maximum. Water absorption 1%. Alright, 863, the size and radiation. The ballast should satisfy the size gradation requirements of table 8.5. 65 millimeters, 5% maximum. 40 millimeters, 40 to 60%. 20 millimeters, not loaded, not less than 98% for the machine cross, not less than 95% for hand broken. Alright, 864 oversized ballots. Retention from the 65 millimeter square mesh on the side with a maximum of 55 ballots retained with a 64 millimeter sieve allowed with deduction and payment. In this case, the ballots retained with a 65 millimeter sieve exceed with 5% but less than 10 payment with a 5 reduction and 5 in the contract rated with is made with the full stack. Stack retains more than 10% ballast with the 65 millimeter size with the rejection of the 40 millimeter square mesh sleeve. In case the ballast retained on the 40 millimeter square mesh sheave C. The machine crush only exceeding 60% limited described above the payment following the reduced rate made for the full stack in addition with the reduction as worked out above. 5% reduction contracted rates and the retention of the 40 millimeter square mesh for the C between the 60% excluding and 65% including. 10% reduction contracted rate and the retention of 40 millimeter square mesh size between the 65% excluding 75% and 70% including. In the case of reduction of the 40 millimeter square mesh exceeds 70% of the sack is rejected. In this case, the hand-broken ballast supply 40 millimeter sieve the analysis may be not carried out. The excessive pat may however, ensure that the ballast is well graded between 65 millimeters and 20 millimeters. 865 undersized ballast. The ballast treated with the undersized and rejected the retention of 40 millimeter sieve is less than 40% and the retention of 20 millimeter size less than 98% for the cube crushed ballasts and retention of the hand-broken ballast. 866 the shrinkage allowance. Payment if the growers mentioned either the stack of the wagons without any deduction of the shrinkage void should have with the ballast is supplied with wagons up to 8% shrinkage is permitted with the destination by co-signing verifying book quantities. 867 sampling test. In the following procedure specify the sampling test for the ballast. A minimum of 3 samples of the ballast should be taken with the surface analysis measure done without on a particular date. Even the number of the sacks is appearance should be less than 3. The test of the abrasion value of the impact of the value of the water abrasion should be done with the approved the laboratory of the railway owned laboratories. A list of the laboratory should be given the end of the document. In order to ensure the supply of the uniform quality of the ballast specification given in the table 8.6 should be filed with respect of the sampling and testing exception for the ballast. This test is given in the table that may be carried out more frequently and warranted at the discretion of the railway. On supply with the first 100 meter square cube test for the size of the gradation of the absorption value of the impact value water absorption prescribed if to be carried out by railways. Further supply should be accepted only after the first batch satisfies these tests. The railway serves the right of to terminate the contract as per the general condition of the contract at the stage of itself. In this case, the ballast supply fails to meet any of these specifications. Frequency test for the ballast. Number size for the gradation test on size of 1 sample per meter squared with 0.27 on each stack of the 100% volume and 20 on each stack of the stack of more than 100 per meter squared cube. The 0.27 for 100 meter square apart. And supplying wagons, 1 for each wagon, 0 for 27 for supplying wagons. Abrasion Valley impact water volume water absorption test 1 for test for every 2,000 meter cubes of ballast. 87 collection transportation ballast. The collection of the transportation ballast can be done either by the following method: collecting the ballast of the ballast deposits of the transportating it into the side of the ballast of the train, the collecting the ballast along the side, assess for the putting in the same track directly. The made collection of the side taking into account the proximity of the quarry available to good stone ballast, serve the roads along the side of the railway line for the carriages of the ballast available for the ballast train, turn around with the ballast trains and available for the traffic unloading. 871 the collection of the ballast depot. The procedure of the adopted when the ballast is collected by the ballast depot space along the side of the railway line meant with the stacking the dividing into the convenient number of the zone demarcated for each depot. The diagram indicated the size site detail for the measured stack is maintained. Each stack is in each of the zones. Serial number to operational collection training out of the material should not be carried out at the same time any zone. The ground on which the stacks are made should be selected and leveled. The measure should be taken with the complete stack. The measured stack should be identified suitably with line sprinkling with another method. As soon as the stack is lifted, it should be recorded with the depot diagram, which was always to be kept up to date. The challenge should be prepared after the loading of the ballast in the wagons. 872 collection of ballast along the cess. And the ballast is collected along the side of the set. The inspector chart should maintain the separate register showing the measurement of the sack as well as the disposition from kilometer to kilometer of the sack should be serially numbered between the successive posts and interior. It should be made in the register whenever the sacks are removed with the ballast and to put on the track of the record should state with the place for the removal of the ballast has been used as well as the date of the removal of the track materials passing through the 6 millimeter squared mesh if it was classified as dust limited to 1%. 8.8 methods of measurement. Quantity of the ballast can be measured either by the sack or in a wagon, both measured as described below. The sack measurement should be done with almost a plane firm to ground with a good drainage. The height of the sack should not be less than 1 meter except for the hilly areas where it may be less than maybe half a meter. The top of the width of the sack should not be less than 1 meter. Should be the cap parallel to the ground plane. The side slopes of the sack should not be flatter than 1.5 to 1 horizontal vertical volume of each of the stack should normally not be less than 30 meters squared meters cubed in plain area, 15 meters cubed in hilly areas. or your wagon measurement. In case of the ballast supply being directly and loaded into the wagon's continuous white line that should be painted inside of the wagon to indicate the level of which the ballast can be loaded. The volume of the cubic metrics corresponding to the white line should be also painted outside of the wagon on both sides of the ignition with the paint line mentioned above the short pieces of the flat cut piece for the tie bar. Otherwise, punch for the volume should be welded in the center of all the four sides of the wagon. 8-9 laboratory test the physical properties of the ballast. Following test racks are recommended to judge suitability of the ballast material for the railway track. 8-9 aggressive abrasion, aggregated abrasion value. The aggregated abrasion of the test sample of the 10 kilograms of the clean ballast conform with the following grading of the taken the passing 50 millimeter sieve with the retained 40 millimeter square mesh surface of 5,000 grams, passing a 40 millimeter retained 25 millimeter square mesh of 5,000 grams. A sample around the abrasive chain charge is placed in the Los Angeles machine rotated with a speed of 30 to 33 RPMs of 1,000 revolutions. Sample is sieved the material course within a 1.7 millimeter sieves washed and dried and weighed. The difference between the original weight and the final weight of the sample to be expressed in the percentage of the original weight of the test sample. This value is reported with the abrasion value. Aggregated abrasion value is equal to your original weight minus the expressed percentage of the original weight in the test sample divided by A times 100. The aggregated impact value. Check the aggregated impact test sample to prepare with the track ballast in such a way that the grading of the last and then the 12.5 millimeters sieve the retain on the 10 millimeter sieve of the ballast sample is oven dried, placed duly tamped in the different stage of the cylindrical metal container with a 75 millimeter diameter, 50 millimeter depth, weight weight of A. The cup of the impact testing is fixed firmly in position on the base of the machine. The entire standard test sample is placed in the compact of the 25 stroke of the tamping rod. The test diameter and weight of about 14 kilograms is raised 380 millimeters above the upper surface of the cup and dropped. The test sample is subjected to a total of 15 such blows. The sample is removed the C's and use the 2.36 millimeter C's. The weight of the quantity of retained is measured with the weight B. Aggregated impact value is the depth of your ballast sample minus the measured quantity divided by A times 100. 893 flaking index. And flaking index aggregated the percentage weight of the particle, the least dimension thickness of the less than 3/5 of the means of the dimension less than that particle with the size of the smaller than 6.3 millimeters. The truck ballast sample sufficient quantities taken to provide with a minimum 200 pieces, which is weighted way A. The sample consistently aggregates the C's of the paper the prescribed procedure in series. The C, the flaky material is separated of the weight, and the weight B, the flaxness index is determined by the whole the weight of the material massing of the various C, the expressed in percentage of the total weight of the sample gauge. Flax index equals separated weight divided by the weight and the original weight times 100. 894 specific gravity water absorption test. This sample consisting of less than 200 milligrams of aggregated with wash thoroughly to remove the fine particles of dust. The whole material is drained and placed in the wire basket immersed with the distilled water at a temperature between 22 and 32 degrees Celsius. Then sample is shaken and jolted and dried as per specific procedure. The sample is finally placed in oven shallow tray with the temperature of 100 degrees to 110 degrees Celsius, and then removed with the oven cooled in the container, weighted sieve. The specific gravity water absorption is calculated as follows. Special gravity is equal to the oven cooled container weighted sieve of the B minus A, the weight absorption of the weight by weight equals to 100 times B minus C over C. The weight in grams of the A is the weight of the gram saturated, then the water B is the weight of the gram saturated by the dry air graded air. C is the weight of the grams over the dry air graded in the air. 8.10 assessment of the ballast requirement. The requirement of the ballast should be assessed separately for the correcting deficiency existing of the track, as well as those arising out of the overhaul through the packing, the deep and screen to provide adequate cushioning, mechanical tamping, provide extra cushioning while the converting of the long welded rail. The ballast required maintenance purpose of this estimated with the rising the quantity approximately if necessary of the survey over every 1 kilometer of the rail length. Care should be taken to ensure that the cores of the under the sleeper is not disturbed. In case of the deep screening, the ballast required for the recoupling of the providing of the standard section should be assessed Deep screening of the ballast on the trial basis for this, the divine full depth screening is done for at least 2 to 3 sleepers every 0.5 to 1/2 mile or half kilometer interval. In this case, screening is done with the under the sleepers as well. The quantity of the ballast is required with the deep screening, roughly taken at 1.5% of the existing quantity of the quantity of the ballast based on the field trials. Quantity assessed above what will be the net quality of the ballast required with the recoup. The deficiency to provide a required profile section of the next quantity of the ballast may be enhanced with suitability to say about 8% to arrive at the gross quantity of the ballast needed for the purpose of the procurement in the case of the measurement are proposed to be taken in stack wagons or originating station. 811. The guides ends provision sub-ballast. The sub-ballast is normally made with the granule material provided between the formation ballast in order to distribute the load evenly over the formation. The following points should be kept in mind while the selection of the material for the sub-ballast. The material should be considered for the coarse oil granule substance such as the river gravel, stone chips, quartzy grit, predominant coarse, and ash cinder slag containing the predominant fine, medium, and sand should be not used. Material should not become cohesive, graded, but the uniform consistency should not be more than 4 to ensure the subballast is well graded. Material should not contain more than 15% of the fineness of the measure less than 75 microns. The thickness for the subballast should not be less than 150 millimeters. Summary: the ballast of layer granule material provided below the main around sleepers due the distributed load with the sleeper over the large area of the formation. Angular granule material can be used for the ballast if satisfies certain requirements of strength, size, and graduation. The ballast gets crushed because of the dynamic action of the wheel load, therefore it requires regular maintenance. The thickness of the ballast collection under the sleeper depends on the axle load, type of the sleeper density, and other related factors. Chapter 9: Subgrid Information.